So in order to do the optics or the mechanical optics, so forth, of course, it was all done on board. What you needed to do is use descriptive geometry. So you would sort of put your mirrors in, figure out the approximate placement for it, go through the unfolding of the optics, look at the output of the system, and if it was a nice square, then you were done. But obviously, it took a lot of changes to get that. And so we developed, and at that time it was not a retroreflecting scanner. It was we were just collecting everything off of one mirror into a photomultiplier. And at that time the requirements were that the radiant energy leaving the scanner had to be 120 microwatts or less. And by the time you got back through the collection system, you were down into nanowatts. So it was. No, we had a narrow band filter right on top of the photomultiplier, but even still, it was some real challenges. But we mechanically and optically were ready for the show. The digital guys, unfortunately, were not able to get the whole thing running, but it turned out that people came back from the show and said, "Hey, it was good." I'm not sure what they did, but it's the magic of the marketing department. And then right after that, we just started the design for a retro reflective scanner. So you only see a flying spot maybe about a 1/4 inch in field of view. And we dumped the photomultiplier and got an avalanche diode at that time. It was a company, RCA actually, was in Montreal, Canada. And so we had a new set of mirrors, and so the next thing was just a simple, X scanner. And that worked fine. It really made a huge difference. The photomultiplier was huge. At those days, the thing was maybe 4 inches in diameter and 8 inches long, and it was very expensive. It was very sensitive to vibration. Let's see. Well, the scanner top really didn't change a whole lot. It's almost the same
width of the belt.
Right, basically the width of the belt. And in fact, the first scanner that I designed, I had a curve in the front. This is a sand casting we did right off the start with. And it had a curve so you could get the scanner as close to the conveyor belt as possible. Turned out that was sort of silly, but it seemed to have appeal to some people at that time. And then Dave Masters came over one day and he said, "Ken, is it possible we could put a bar on here? We got the X, but if we had a bar, we could be looking forward." And I thought, I think it's possible. So, and at that time, Frank didn't think so, but I went on my own and I found a way of doing it. And so we were able then to have this X bar scanner. And that was sort of neat because some of the photographs that will be in the museum, you can see where we have this front-looking ability to scan, where before everything had to be just flat on the X surface. And the other thing was sort of interesting is that we needed to design it for 100 inches a second. This would be a clerk scanning at that speed, which we knew was, it'd be just, but that was a requirement. Of course, the Bureau of Health and Radiation, our friends in Washington, had limited the amount of laser exposure because at that time, the laser was just really a new development. No one really knew about it. The unions in the supermarket were against it. They figured it was going to cause clerks to have abortions and all kinds of silly things, and migraine headaches. And in fact, when we tested the first scanner, we couldn't test it in California. Frank and I had to drive up to Nevada, and we tested at a Safeway store in Nevada. That was the best way of doing it. And so the test worked great. Safeway was really a good customer for Datachecker right off the bat. And then the next step is what's called a double X bar, I guess it was. And so the original one, the bar was sort of at the top of the X. It almost looked like a Roman symbol, a number symbol. And we moved that down to the center of the X, and then we put 2 more X's sort of shifted on that, which increased the scanning range for the scanner. And that's what we went into production with. And
increase
the range, the flat range, this way. We sort of stretched out the envelope for that. And the depth of field is sort of interesting. You just reminded me of it because, at that point we had no idea what the spot size should be. And so I had designed a beam expander so that we could take the 1 millimeter beam coming out of the laser, and we could focus it down to any size we wanted to. It was just a question of selecting the right lenses. And so what Frank and I did is we made up 3 or 4 different beam expanders, and we put it in the scanner, and Frank actually was scanning different things because the problem is that the bigger the spot, you have less resolution, but you have more depth of field, and vice versa. You know, if you get down to a real, because you're trying to read some of these really small symbols, your inclination was to have a very small spot, but then your depth of field is very, very narrow. So we went through these different beam expanders, and we declared this combination of lenses as the winner. And I can remember Frank saying, "Now this is the most secret information we got. Don't ever accidentally mention that to anyone else, because this is so." And I forgot what this was so long ago. I forgot what the diameter was, but I thought that was sort of interesting. Then the next thing that I thought was sort of interesting is when we were going to go into production, because National Semiconductor was a great manufacturer of semiconductor stuff. But the point of sale division was sort of new, and it was almost like you don't belong to this company kind of thing. So we had showed Fred and all the people that were the powers to be, that this thing had the performance that it was needed, and it was time to go into production, which Fred really wanted to do. But the manufacturing manager for that division said, "No, it's not ready. I don't think it's ready. I'm not gonna do it." So Dave said, "Come on, Ken." And so I went over to Dave's house, and and he's really a wizard with woodworking equipment. I learned a lot of woodworking equipment that day, and we built up enough of assembly boxes and burn-in boxes, basically burn-in boxes for the scanner. And we went ahead and got a room to ourselves. We did the first 50 scanners in this room. We burned them in. Created our own mini manufacturing system, and they were shipping them. So finally, the fellow said, "Okay, I think it's ready for production. I'll take it over now." So that was sort of interesting. And I was talking to Dave the other day, and he says, "Yeah, you learned a lot on the woodworking that day, didn't you, Ken?" I said, "Yeah, I still have my saw in the garage now."